So yeah, please keep remind me. I sometimes forget things. So if we want to find some probability, we have these three conditions. Either we want to find the probability for less than area, which is directly you can calculate from table, but you have to change x to z. You can find probability if it is on the right hand side by taking total area, which is 100% 1, and less than that particular value, probability of x less than equal to z. And if you need to find probability between two values, like between a and b, so if it is between a and b, then we can say probability of z less than b, upper limit minus lower limit. Now we see some examples from this table. So I have made this slide. If probability z value, because this table is z value table, then what is the probability that it is less than 2.50? I am repeating, 2.50 is a positive number, so I go to the positive because there are two sides. One is negative side and positive side. 2.5 is here, and corresponding to the second decimal place, which is 0, we found 0.9938. So whenever you want to find some particular value in the z table, this is z table or standard normal table, then in this table you find the first decimal place value in this row and the second decimal place value in this column. If I want to find, for example, 2.50, so I will see 2.5 is here and the second decimal place, which is 0, is here. So I see column wise, first column and this row, I found 0.9938. So when you want to find probability for the z function, for the z, like z is here, then you can do it directly from this table. Second example that I had, probability of z less than minus 1.30. So I go to the negative side, minus 1.3 is here and the decimal place 0.00 is here. So we see, if you concatenate, basically 1.30 is a concatenation between minus 1.3 and concatenate operator 0.00. So this is giving me 0.09680. So it's, if it is z table values directly, it's so simple that you just see the table and get the answer. There are a lot of online tables as well that you can use. I can show you one table where we have these values. For example, I want to find value below my 2.50. So just recalculate and it is giving me result. And if we want to find some particular other value, for example, minus 1.30, then recalculate 0.096. If I want to find values between, suppose if it is between what the value, if it is between minus 1.3 and 2.5, then we do upper limit probability z value, upper limit of z value, lower limit of z value. We have found that upper limit value probability value is this and lower limit value is this, and the area is 0.89.7% area lie between minus 1.30 and plus 2.50. If I go back, you see it is the curve which is a standard normal because the mean value is 0. The standard deviation is 1. You can see 0 minus plus 1 standard deviation minus plus 2 standard deviation and so on. Because you see 0 is the center, so negative value is minus 1.3 starting point is here, and the upper limit, which is 2.5, you see this is here. So between minus 1.3 plus 2.5, you see it's a big chunk of the whole curve, which is equal to 89.6%, 89.7% of the total. So this is a way you can use this calculator, and but for practice purpose in practical life you will be using table online tables. but on the academic side, you will be using paper-based tables. So that's why that's a way to find probability. But if you want to find probability of X, suppose less than 41, where mean is equal to 30 and standard deviation is equal to suppose 10. Suppose we have a question where we want to find probability not by Z table but by X values. What we have to do? That means if you have question in X, first you have to transform it. X minus mean, which is mu. I am typing in English, not the Roman. Sorry, the equation format divided by standard deviation, and less than 41. 41 minus mean divided by standard deviation. This is called, first you have to convert your question from X to Z. So we can say first convert the question from X to Z random variable. X random variable to Z, that means you have to standardize your variable first. Once it is standardized, then it becomes Z less than 41 minus 30 and 41 minus 30, whatever with the answer, and divided by 10. So 41 minus 30 is 11. 11 divided by 10 is 1.1. 1.1 may be written as 1.10 because we need two decimal places. After the decimal, we need two places. If I go to the normal table, because it is below area, it is less than 41. So below area, I just cite 1.10 and I calculate. So it is giving me 0.8643. So this probability is 0.8643. So you see, we can directly get the picture as well. Oops. So we can get this picture. You can copy as well. HSCS1 sorry, removed. So we can see. So we can see you can directly use this online calculators. There are a lot of many, and you can use the paper-based table. For example, 1.10, I go to this table where is 1.1. 1.1 is here and 0 is here, 0.8643. You will get nearly same answer. If you are using other programming languages, other calculators, you might have a variation in 4th place or 6th place. But because we are calculating probability till 4th decimal place, there is no problem. You can use any, even in your calculator, scientific calculator, you have this option to calculate probabilities. Similarly, you can try if you need to find any value which is greater than 21. So first you have to convert 1 minus probability of X less than 21. I told you that if you want to find area above some point, first you have to convert this into below, less than. But you see in online calculators, it is above option as well. So, but in tables, we don't have this option. 21 minus 30, it is 9. 9 divided by 10 is 0.9. So if I see, look, it is giving me area above 21. So this is the way. Sorry, 1 minute. 21 minus 30 is minus 9. Minus 9 divided by 10 is minus 0.9, not 0.9. So this is the area from minus value till this point. So this is a way to calculate probabilities either using this table, this online calculator, or using the standard approach, which is by using the table. Between two values, you can again see if you have problem given in X format, first you have to convert into Z notation. After converting into Z notation, then you can solve it. Is it clear? Also. So this is that conceptual way. You don't have to do any integration. Otherwise, it will be very difficult to do these things. This is a simple question. A radar unit is used to measure speed of cars on a motorway. Like, you know that highway police have vehicles that can measure the speed. The speeds are normally distributed with a mean of 90. So average car speed is 90 km per hour. Where is fluctuation, like small cars, four-wheel drives or whatever, there is a variation of speed like 10. So 90 minus plus minus 10, or 90 plus minus 2 times 10, or 3 times 10. What is the probability that a car picked at random is traveling at more than 100, more than, greater than 100? That means we need to find probability of x greater than 100 equal 1 minus, because I told you that if it is greater than, first you need to convert into less than. We did conversion, and from this you can say 1 minus probability of, now we first convert into z distribution. 100 is the x value, minus mean value is 90, divided by standard deviation is 10. Luckily it is 10 divided by 10 is equal to 1.00. I can go to table. 1.00 is 0.8413 here. 1.0 from here, and second decimal place from the column, we found 0.8413. And if I go to the online support, if I go to the online page, 1.00. Sorry, no. So if I click 0.8413 or something, so similar answer. So you can see that we can find the answers using either this online calculator or using this standard approach, which is tabular approach. Any questions? So you can use this online calculator here. There are many questions that you can do. I type it again. Oh, sorry. So there are duplication. This is the same similar question, and you have to find the probability between 50 and 70. So you have to remember that you see one thing which is important. Mean is 50 hours. Standard deviation is also 15 hours. So we need mean and standard deviation having the same unit. Suppose mean is in hours and standard deviation is in minutes. So first you have to convert minutes into hours, or the hours into minutes. So both mean and standard deviation must have same measurement unit, same unit of measurement. Okay, here's the screen size. Now, why it is so important in normal distribution is so important in most of the statistical analysis. Basically, what you have studied today, this is the key in many data science and data analysis projects or challenges. So if you want to see whether your data is normally distributed or not normally distributed, so you have to do first histogram. You know histogram. You have to see, is it the histogram a bell-shaped graph or it is not a bell-shaped graph. Then you see the descriptive statistics. You remember from second, third slide that if mean, median, mode are very similar to each other, that means the data might be normally distributed. Third thing that you have to check, 2/3 is approximately 66 or 68% of the observations. Do you think that if you have suppose data, you are given a data, you calculate the mean, you calculate the standard deviation, and then you do mean minus standard deviation, you will find a number. Mean plus standard deviation, you will find another number. Then you will check, you can use array, or you can use manually, that how many observations lie between one standard deviation, mean minus standard deviation, and mean plus mean plus one standard deviation. कुछ समझ नहीं आता. If you have any question, you can ask. I told you again and again. So, and if you don't have any, so remember this, you are a university student. You are not in the college. And so, okay, so I will continue. So these are the properties that we usually see, that we'll usually check when we are doing data science projects. So this is an approximate normal distribution. You see that it is a bell-shaped curve. It's easy. I am not going to discuss QQ plot at the moment, but if you see this curve, you see this is not a normally distributed curve, and you can have a lot of high variations between from the straight line to a straight line means normal. If all the points are on the straight line, that means it is normally distributed, like you see here. If it is not on the straight line, that means your data is not normally distributed. It's another issue. If it is right skewed, then we see it is right skewed, then we have a very high shape. You see variations in this graph. Sometimes, okay, leave this because this is a practical application. We have not reached the point where I can explain you what is QQ plot. But this is a way in practical life that we see whether the data is following a normal distribution or not following a normal distribution. Okay, till now, do you have any questions? Then I will continue to explain the next topic, which is like the last topic for today. And then we will have some practical.
सर जो टेबल जो देख रहे हैं 1 डेसिमल प्लेस तक देख रहे हैं मतलब 2.5 है सर 1
Okay, so we can find the probabilities using, as I explained. Now, there is a problem in binomial distribution. You know, binomial distribution have two parameters. One is called the number of trials, and second one is called the probability of success. In binomial distribution, okay, I can read from here. If the random variable x has the binomial distribution with parameters n and probability of success p, then for large n, what is mean by large n? Whenever it says large n, that means n is equal to 30 or 50 or 100 or more. In statistics, if you have sample size of 30 or more, that is called a large sample. You will assume why sample size 30 is a large sample, because the statistics that was developed in 1950s, 60s and 70s, at that time there were no computers, and working with sample size of 30 was assumed a big number. But you are computer science students. If I say generate 1 million numbers, 1 million random numbers or numbers, you will just say, okay, no problem. And you will write a 1-line command and you will get 1 million numbers in just 1 or 2 seconds. But because we are doing something which was developed 300, 400 years ago and equally useful nowadays as well. So we assume n is 30, 50 and 100. So this is the theory which we are studying. And in practical life, if you go for some extreme engineering project, for example, you have to test a engine, Rolls-Royce engine. You cannot have 30 engines for testing. You can have only 2, 3, maximum 5 engines for testing. For example, if you have to do some brain tumor research and you need brains from the living human being, you cannot take brains from living human beings. So you have to do some other thing. Or maybe if you can have from somewhere, somehow, you can have 1 or 2 brain for brain tumor research on living cells. So that means in some complex sciences or complex engineering, you cannot have the liberty to have sample size of 30, 50 or 100. So but in general science, for example, social science, for example, do you like coffee or you don't like coffee, or do you like Cadbury or do you like Mars? So you will say yes, no, yes, no, yes, no, many responses. So but in extreme engineering, no, this is not possible. This is the difference. But in case if I want to transform into z, so basically when n is large, we say z is equal to x minus mu. You know, in binomial distribution, the mean equals to np and variance equals to npq. You can see lecture 2 and see that standard deviation becomes under root or square root of npq. So that means from binomial distribution, which have two parameters NP, we moved to Z distribution, and then we can calculate probabilities using Z distribution. So this is a good transformation. If you have very large N, so that means you don't have to worry about anything. You just can use normal distribution in place of binomial distribution. But if you have a moderate value of N, moderate means 25, 30, 35, 40. So that means you have to do some corrections in your data. You know, binomial distribution is a discrete distribution. Discrete distribution means you are counting 1, 2, 3, 4, 5, 6, and so on. But if you go to normal distribution is a continuous distribution. That means 0.01, 0.02, any continuous number. So when we convert from discrete distribution or discrete problem to a continuous problem, we have to make some changes. This is called continuity correction. That means we are approximating our discrete distribution using a continuous distribution. Any question? So for example, I explain here. It's a bit tricky. For example, I type in the PowerPoint. Can anybody tell me what is the number if I write less than 15? So can I write probability of X less than equal to 16 or less than equal to 14? I am saying the X value is less than 15. So what will be it will be equal to if it is like discrete number 1, 2, 3, 4, 5, 6?
Less than equal to 14.
Less than equal to 14. Yes, because you know the left hand side. So the next number, if you remember in year 8 or year 10, you studied number line. So from the concept of number line, if I can find any image, yeah, got it. You can see number line, and in the number line you can say -1, -2. So for example, if I say less than 3 will be 2. If I say greater than 3 will be greater than equal to 4. If I say, now second thing, if I say less than equal to, where is PowerPoint? Where is PowerPoint?